In this video, I'll be continuing to use the file path and files types, but I'll start with a new project called File and Path. I'll start by creating a private static void method named useFile. This takes a string, a file name. I'll create a new file variable named file and get a new instance via the single argument constructor on the file class that takes a string, so I'll pass it file name. Next, I'll create a boolean file exists and assign that the result of calling the exists method on my file instance. Using a formatted string, I'll print the file name and whether it exists or not. I'll use the file exists boolean variable to adjust my output message accordingly. If the file exists, I want to start out by deleting it because I'm going to always recreate this file in this code. To do this, I'll set up an if statement checking the file exists variable again. If that's true, I'll first print a statement that I'm deleting the file. Then I'll execute the file.delete method on my file instance. I'll assign notFile.delete to my file exists variable. If this file can't be deleted, meaning I get a false back from this method, I'll set file exists to true. This is because I'll be using this flag later to determine if I should continue. Next, I'll create another if statement, this time checking whether the file doesn't exist. If it doesn't exist, I'll call file.createNewFile. This returns a boolean, but for now, to keep this code simpler, I'll ignore the result. There's a chance this could fail, and I wouldn't really know because my code would indicate everything was fine. I'm going to talk about this more a little later. I'll print a statement after this that the file was created. For good measure, I'll test if this file can be written to, and if so, I'll just print that I would write to it here. The file method by itself doesn't have any methods to write to a file resource. Right now, I'm just printing something to the console. Notice that I've got an error on the createNewFile method. If I hover over that, I can see that I need to handle an I/O exception. I'll just use the More Actions link and pix around with try catch there. Instead of throwing a runtime exception in this generated catch clause, I'll just print something went wrong instead to the console. I'll call this method from my main method, passing it a string literal representing a file name, testfile.txt, running this code for the first time. I'll get the statement in the output. The file testfile.txt does not exist. I can see the code created the file and that it would write to the file, which means the canWrite method returned true. If I open my project pane, I can see my testfile.txt file there in the projects directory, so it was successfully created. If I run the code a second time, I can see that my code recognized that the file does now exist. This is followed by the statement deleting file. Then my code creates it again and would write to it. To summarize, in this code, I used an instance of file to test some conditions in the file system as well as to create and delete a file. I'll do the same thing, but I'll instead of using an instance of the older file class, I'm going to use an instance of the newer path type with the help of the methods on the files class. I'll copy this entire method and paste a copy below the useFile method. I'll first change the name from useFile to usePath. I need to replace the statement here where I create a file instance. First, I'll create a path variable simply called path. In the last video, if you remember, I used the get method on the paths class. JDK11 introduced a static factory method on the path interface itself, a method called of, so that's what I'll use here, passing it my file name argument. Right away, that gives me 4 compiler errors everywhere where I was accessing the file instance. I'll need to replace each instance, first replacing the file variable with the file's class name, and instead of passing no arguments to each method, I'll pass my path instance. First, I'll do that for the file.exists method, changing file to files and passing path to the exists method. Next, I want to do the same thing for file.delete. So changing it to notfiles.delete passing path. In this case, I've got an error after I make those changes. I'll come back to that in a moment. I'll keep going with the file to files replacement, so next I need to change create new file. After I make that change, I can see I have an error here as well. That's because the method doesn't exist on files. Again, I'll come back to this. I'll next change file.canWrite to files.canWrite and pass path to that method. There's another error because as before, this method isn't on files. Okay, let's address each of these issues, starting with the delete method. I can hover over that, and now I see the delete method on files throws an IO exception, so I have to either catch or specify. I'll pick surround with try catch here. Now I have a different error, and this is another difference between the delete methods. Because the one on this class throws an exception, when there's a problem, it doesn't return a Boolean value, or any value for that matter, it's void. I have to change my code. I'll remove file exists, the assignment, and the not before that method call. I'll set file exists to false after that delete statement. I also don't want to throw a runtime exception, so I'll change the generated catch clause. I'll remove that throw new runtime exception statement too. Instead, I'll just print the exception. The delete method is all good now, so moving down to the create new file method, I'll delete that method including the dot, since it doesn't exist on files. I'll enter a dot again so that IntelliJ display a list of methods available on files. Here you can see create file near the top of the list. I'll pick that one. This change seems to be fine, and I already have it in a try catch block. The one difference I do want to point out to you is the files class's version to create a file doesn't return a Boolean as did the file class, which returned true for success and false for failure. Similar to the delete method, it will throw an exception for a failure. This feels like we're moving from a look before you leap approach to an easy to ask for forgiveness response, doesn't it? Moving on to the canWrite method, I'll delete it and the dot, and then retype the dot to see the list of possible methods. Right away, I can see an isWritable method, so I'll select that. Now everything compiles, and that wasn't too painful. I'll add a call to this method with a different file name in the main method. I'll call usePath, and my file name will be pathfile.txt. I'll run this. In the second set of outputs, I can see file pathfile.txt does not exist, and that the code says it was created and that it can be written to. Again, opening the project panel, I want to confirm it's been created, and sure enough, I can see it's there. All I've really demonstrated by this exercise is that you can do the same thing with files and path as you can simply using a file instance. But now, let's make another change to the usePath method. Here, after I test if the file is writable, I print this statement to the console. This time, however, I really am going to write to the file. I'll call a method named writeString on this file's helper class, again passing it my path variable, and a string as the second argument. I'll pass it a text block with several lines of text. I want this text to be written to my newly created file. I should see what is typed here in my file after this code is run. I'm getting the error that says this throws an unhandled exception. Rather than surround this with a second try catch, what I'll do is include this code with the code above it in one big try catch. I'll cut the catch clause I have above this code. I'll paste that after my nested if statement. I can reformat that with the Ctrl-Alt-L on Windows or for Mac. I'll delete line 65 because we have now implemented code to write to file, and this comment is redundant. Running with that change, I can now open that file, pathfile.txt, and there is the text from my text block. Okay, that was super easy to do. I can also read this information from the file just as easily. I'll add a couple of statements after that isWritable if clause. I'll print that I can read too, following that with a separator line. And now in a single line of code, I can call the read all lines method on files, again passing path, and then chaining a call to the for each method, passing that a method reference to println. Running this, I can see in my output the statement, and I can read too, followed by dashes. After that, here are the lines that the code read from my text file printed to the console. I'll be talking more about reading and writing to files in future videos, but that's just about as easy as it gets. Okay, let's quickly look at some of the functionality the IO and NIO2 methods have in common on a slide. This slide shows you quite a bit of the functionality you'd expect from a file system and the methods you'd use for each of these classes. You can see the methods are often similarly named, and methods exist for all the basics. I'm not going to go through each of these individually and compare them to each other. What I want you to remember is, if you need to support legacy code or if you need to be backwards compatible to a version of the JDK that's older than JDK 7, you can still rely on the file class. If you're starting out new, I'm recommending you use the files class, files with an S, and a path instance, otherwise known as the NIO2 way of doing things. Let's review why NIO2 is better under the covers. First of all, file operations have been improved. The NIO2 types include support for asynchronous file I/O operations, file locking, including more granular locking. This means instead of locking the entire file, a region of it can be locked. There's enhanced support for file metadata retrieval, as well as new support for symbolic link manipulation. Finally, the NIO2 types have support for file system notifications. This means changes occurring on a path can be made watchable to registered services. I plan to give you an example of this in the concurrency section of the course, where it should make more sense. The NIO2 types have been designed to be better performing. NIO2 types are non-blocking, meaning asynchronous access to resources by multiple threads is supported. They manage memory more efficiently, reading and writing files directly to and from memory into buffers through something called a file channel. I'll be covering reading from and writing to files shortly, and I'll discuss the file channel and its advantages. You can also read from or write to multiple buffers in a single operation, which I'll be showing you as well. At this point, I'll be switching to just using the files and path code, otherwise called the NIO2 types, and focusing on the functionality these types offer us. In the next video, I'll cover directory listings and related topics, so let's move on. See you in the next video.